R, correlation coefficient. Okay, the range of correlation coefficient is what? -1 and +1, correct? If it is +1, we call perfectly positively correlated, and here perfectly negatively correlated at -1. If it is 0, that means no correlation. Okay, just for your reference, I want to mention that, or you can write also why it is denoted by R, because it is called rho, and it is something like this, the sign is like this, P, a little bit bent P, understood? Rho, Greek letter. Okay, now when you have a zero relationship, see how R is calculated, some X you will take, some Y you will take. If X is this much, Y is this much, X is Y is this much, X is this much, and then you apply the formula and you get R. Okay, understood? We will be doing the sums, but wait, let us go slow. Now X is runs of Kohli, Virat Kohli, and this is sense X. Obviously when you take figures now, when Virat scored this much, sense X was this much. When Virat scored this much, sense X was this much. Now there is no sensible relationship. You will get something R. You will get something R, 0.05 or 0.1, anything you can get. Understood? But you should understand this is a spurious relationship. Spurious means it's a nonsense relationship. There is no relationship between the two things. Does sense X move according to Virat Kohli's score? No, na. It's nowhere related. Okay, there is no cause-effect relationship. That is what we call. Okay. Please write one formula in your book. R is equals to summation x minus x bar into y minus y bar upon underscore summation, sorry, not underscore, summation x minus x bar the whole square. Okay, and summation y minus y bar the whole square. Is it clear? Here in between there is a multiplication. Dot means multiplication. Is this clear? Correlation just give us and make us understand the strength, between the strength of relationship between the two things. Okay, is that clear? Whether it is strong, whether it is moderate, or whether it is low. That's it. Okay. Write one more formula. R is equals to covariance of x comma y upon standard deviation of x into standard deviation of y. Okay. Listen, now you will ask me, sir, what is covariance? We have heard variance. Variance is what? Variance is deviation of the asset from itself. Yes or no? Deviation of the assets from its average. Covariance means what? Co-movement. Covariance means what? Co-movement between x and y. So summation of x minus x bar into y minus y bar upon n. See, the deviation of x with the mean multiplied by y minus y bar. I want to clear you. Listen carefully. Take x minus x bar, make a column of that. Take y minus y bar, make a column of that, and then you have to multiply, and then you have to take the summation. You understood what I am saying? X minus x bar, this will one column. Y minus y bar, this will be another column, and then one more column, x minus x bar into y minus y bar, and then the total of this is nothing but the numerator. Are you understanding? Is that clear? Below what you will do, x minus x bar the whole square and then the summation, y minus y bar the whole square and then the summation. Correct? You understand? Covariance means co-movement. R was what? It showed us the relationship, how strong the relationship is, right? This just gives us the direction. Only it specifies the direction. By looking at the numerator, what do you think? What do you think? The answer will be in percentage or percentage square? Yes, covariance answer will be in percentage or percentage square. X minus x bar will be in what? If x is in percentage, x minus x bar will be in percentage. Y minus y bar will be in percentage. If you multiply, what you will get? Percentage square. So anyways you are dividing by n na. N so does not have that percentage square na. So obviously this will be in what? Percentage square. Understood? Is that clear? What I wrote now here this formula, how I derived this, I will tell you. Listen, R is nothing but covariance x comma y. Listen carefully what I am saying. Standard deviation of x into standard deviation of y. Covariance formula is summation x minus x bar into y minus y bar upon n upon standard deviation under root summation x minus x bar the whole square upon n. Correct? Into summation under root x y minus y bar the whole square upon n. Yes or no? Correct? This can be written as root n. This can be written as root n. Root n into root n in the denominator becomes n. So n here, n in the numerator get cancelled. Ultimately you are left with summation x minus x bar into y minus y bar under root. Okay, you can take it common also or separate also. Summation x minus x bar the whole square under root summation y minus y bar the whole square. You understood? This is what the formula I have given here. See? Understood? R na R, this covariance is an absolute measure. What I mean by absolute measure means its range na is from minus infinity to plus infinity. The only if let's say you have calculated covariance, it is coming something 10,000 and there is one more covariance which is 500. There is nothing it can say whether it is high relation, low relation, nothing. Means it has no definition, it is only an absolute measure. The use of covariance is that it helps us to calculate the R, and the R na it gets its sign plus or minus from this covariance. If covariance is negative, understood? Covariance is negative, then obviously the R will be what? Negative. It only gives the direction. If x is moving up, y will move down, then the R will be negative, means covariance is negative. Listen, this is the formula for R. This is the formula for R. Standard deviation, if you remember what I said, standard deviation will always be positive, correct? So this to will always be positive. This to will always be positive. Then R to, if covariance is always positive, R to can not be negative, na? You understand? So R, are you understanding guys? R gets its value from the numerator, means plus or minus sign from its numerator, because denominator always it will be plus, because it's standard deviation, na? Correct? So numerator can be plus 10,000 or minus 500, whatever it is. Only the value can be extreme, means covariance, like R I said now, -1 plus 1. Covariance can take any values. Is that clear? Understood? It's just a means I can say it's one concept of R, that's it. But it does not say, means there is no, means this magnitude now, it does not resemble anything. It just gives the sign, that's it. The main purpose of calculating covariance is it helps us to calculate what? R. Is that clear? R is a more broader concept than what? Covariance. Is that clear? In the previous part, what I wrote is x minus x bar into y minus y bar. Correct? Now this na is nothing but x minus x bar the whole square. You understand what I am saying? So this is nothing but this is variance. Means you understand, the deviation of x with the x bar and y minus y bar, when you take the product, it is covariance between x and y. Understood? Deviation of x minus x bar, y minus y bar. It is deviation between the two things. Now, if you are feeling it is difficult, when we will take the numbers, it will be easy. Is that clear? So don't take that stress. I am just explaining you the maths. Here, this is x minus x bar. Here it is y minus y bar. Means it's a deviation between the x and y. You are taking the product of the deviation between the x and y from its average. When I take the deviation of the x minus x bar with the x minus x bar and the product, it is nothing. but it's a covariance only. But it's covariance between what? Not x and y. It is covariance between x and x. That is nothing but variance of x. That is nothing but variance of x. This wasn't variance of x upon n, isn't it? Correct now? So variance is nothing but variance is a special case of covariance. Variance is a special case of covariance. Okay, is that clear, guys? Understood? If many time in one exam what happened, we will also do that sum, but it was given like this: a b a b. Here it was 100, here it was 200, here it was 1500, here it was 1500. Understood? And they wrote covariance table. Okay, can you tell me what is this, what is this, and what is this? If you see, this and this is same, because it is covariance between AB and covariance between BA, means one and the same. Understood? But this is different, and this is covariance of A with A. Covariance of A with A is nothing but variance of A. Student didn't understand in the exam. Matrix form. You understand? So you should understand. Covariance of A with A is nothing but variance of A. If I take the root of 100, what I will get? Standard deviation of A. Right now, if I take root of 200, I will get what? Standard deviation of B. Correct. This is what? See now, I hope you understand. This is B. This is B. This is covariance of B with B. This is A. This is A. Covariance of A with A. Are you understanding? When the covariance is negative, if the covariance is negative, it means what? The behavior is opposite between X and Y. If the covariance is positive, means their movement is in same direction. If one goes up, other also goes up. That's it. Now, no other interpretation. Is that clear? Understood? Covariance tells us the direction, the behavior between the two variables. If someone is feeling that Chinese movie is going on, please be careful. Understood? I hope you are understanding, guys. Right. Covariance formula. Case 1. If number of year is given, means historical data. Okay. Number of year, number of observation, that is given. Then in that case, covariance between x comma y is equals to summation x minus x bar into y minus y bar upon n. Wow. And case 2, when standard deviation and R is given. What is R? Correlation. Instantly it should come. Understood? Covariance between x comma y is equals to R into standard deviation of x into standard deviation of y. Have we done this formula? Yes. Have we done this formula? Yes. In R we have already written. See here. In R we wrote this now. If I want to calculate this, I will take this denominator on the other side. Yes or no? That is what you just wrote. R into standard deviation of x into standard deviation of y. Is that clear, guys? Okay. Case 3, when probability is given. Okay. See, when probability is given, if you remember now how to remember the formula. Can anyone has that guts to tell the formula when probability is given? Looking at the case 1. Yes. That's it. N will not come. Okay. See people how smart they become after only 10 lectures with me. Understood? They can make even the formulas. Right? I am just kidding. Huh? Clear? Understood? Only n will not come. In numerator, probability will come. See, this all instincts now you should develop. You remember I explained you at that time also, because here na denominator will be summation p, but summation p is what? Probability is always 1. So denominator, yeah, summation will go. Is this clear? Okay. Done. Okay. I want to discuss, yesterday we left one part, which I said we will discuss in next episode. Yes, I'm coming to that part. Yes, here. I want to discuss this. I was not satisfied with the discussion. This is theory page number 128. Correct? Here, the return of the x was 15%, return of the y was 15%, return of the portfolio was 15%. You remember 50% in each, and we created a portfolio. But when you calculated the individual standard deviation, it was 14.4. Here it was 14.4, and here it was 9.49. Means risk what? Reduced when you made a portfolio. 50% in each. Investment was 50% in A, 50% in B. Am I right, guys? Then we discussed that the portfolio on a standard deviation is not weighted average of the individual security. Weighted average means 0.5 multiplied by 14.14 plus 0.5 multiplied by 14.14 will be nothing, but it will be ultimately 14.14. Correct na? Yes or no? But portfolio was not this na. Portfolio return was something different. It was 9.49. Am I right? Correct. So I was not satisfied. I want to read this once again. To take the weighted average of individual security, standard deviation would be to ignore the relationship or correlation between the return of the two securities. If you take weighted average like I did here, if I take this weighted average, that means I'm ignoring what? The R, the correlation, the movement between the two things. Okay, and correlation between security return complicates the calculation of the portfolio standard deviation, and that R na, because of that R, the portfolio standard deviation, the portfolio standard deviation of the P portfolio gets complicated, they are saying. Okay, by requiring us to calculate what? Covariance. First you will calculate covariance. Understood? Between the returns of every possible pairwise combination of the securities. Covariance just now we did na, the same thing. Is that clear? So we will do one sum, one light sum. Okay, first we will learn how to calculate covariance. Then I will make you understand what we were talking about. This means in simple terms they are saying simply you can't take weighted average. It is not weighted average. You are as I said, see, covariance and R, these two are related. Understood? So you are ignoring covariance and R between the two securities, and because this R is present, correlation is present between the two things, therefore the portfolio standard deviation calculation becomes complex. So after doing one sum, we will move into that complexity. Is that clear, guys? So these all things are done. Okay, yes. Now this table is given to write all those formulas. Okay, so it's homework for you to write this in this table. See, here also formula space is left. Okay, this is homework, so that one more time there will be revision for you. Okay. Okay, so let's move to question number, let's see which question we can do. 9 is done. Let's calculate question number 10. Yes, sorry. See, find out the covariance of the following data. Now first thing na, if someone is not understanding how to make the tables and all, you should see what question is asked. They are asking what? Covariance. You should see the data type. It is probability, right? It is probability is there. It is written portability, but it is probability. Okay. Okay, all these mistakes are purposely done so that you don't sleep in the class. Right here, probability. Okay. So listen. So what is the formula for probability? When for covariance formula for when you have probability x comma y. First you should write the formula summation. Say the formula p into x minus x bar y minus y bar. So first thing what you should calculate is x bar, right now? Okay, when probability is there, how you calculate x bar? Expected return. How you calculate? Probability is given, x is given. How you calculate x bar? x into p. X into p. First you will have to do this. You will get expected x bar here, expected r. Yes or no? Y into p. Expected. I made so many times. Expected means what? Whenever I use the word expected return means return of x. Expected return on x means return of x multiplied by probability and the total. Expected return on y means what? Y expected return on y multiplied by what? Multiplied by probability and then the total. So this is your y bar. Once you do this, x minus x bar and then y minus y bar. Understood? Is that clear? Then x minus x bar into y minus y bar because correct, into probability because this you have to take summation of this. What this summation signifies, everything on the right hand side you should do and then you should take the total. Those who are not knowing, those who have not done +2 level maths, summation means what? You should take all these things and then the total. So I will take x minus x bar, y minus y bar, multiply by probability and then I will take the total of this. Understood? Let's go. So now we are ready to jump into the sum. So let's solve. Yes. What a smart batch. Huge strength. Question number 10. Computation of. They have asked only covariance. But we are very good students. Okay. So I will also calculate R also. Yes. Okay. So please help me out. Okay. Computation of, I will write expected return first. Computation of expected return of x and y. Computation of expected return of x and y. Condition is given. Bullish. Bullish means what? Bullish. Market condition is bullish. Bullish means the market is, you are expecting the market to go up. Understood? Bearish. Bearish means what? The market is going to go down. Right? Understood? You know why bullish is called bull? No. Because bull, it hits up like this. And bear, it hits like this down. Understood? Scam 1992. Yes, in scam 1992 it was there. Okay. Probability. Then x multiplied by probability, y multiplied by probability. That's it. Okay. X is 40, 20, minus 15. I'm copying from the book. 30, 25, 18. Probability is 0.3, 0.5, 0.2. Okay. X into p. 40 into 0.3 is how much? 12. 20 into 0.5, 10. 57.5 minus the total comes to 12, 22, 22 minus 19. How much it is? No. How it can be? I made some mistake. 0.3 is minus 3. Okay. So final answer should match. That is 19. Okay. In exam also final answer should match. 9. 25 into 0.5 is 12.5. 18 into 0.2 is 3.6. 15, 15, 16.1, 16.1 plus 9, 25.1 is the answer. This is expected return of x and this is expected return of y. Wow, what a sum. Done. Please copy fast. Use both your hands, left hand, one column, right hand, another column, like that you should use. Okay, within 1.5 hours you should be able to complete your paper if you use both your hands. Like Viru Sastra Buddhe. Right? Computation of covariance condition, bullish, stable. Done now above table. Okay. Stable, bearish. Then probability or Rx I can take. Then Ry I can take. Then probability. Okay. Rx is how much? 40. Correct. 20 minus 15, 30, 25, 18 I can take. Probability is 0.3, 0.5, 0.2. Then Rx minus Rx bar, that is expected return. Then Ry minus Ry bar. Okay. And then multiply of this two column. I will give this as A, this as B. So A multiplied by B. Okay. Rx was how much? 19. Ry bar was how much? 25.1. So you know how to complete this, right? Please complete it. 40 minus 19. How much? 21. 20 minus 19. 1. Minus 15 minus 19. Minus 34. Yes. Then Ry minus R bar. 30 minus 25.1. 4.9. 25 minus 25.1 minus 0.1. 18 minus 25.1 is minus 7.1. Okay. 21 multiplied by 4.9. How much? M plus. Use M plus. 30.87 M plus. Sorry, into probability also, na? Into probability also. Okay, how much it is? 21 multiplied by 4.9 into 0.3. It is 30.87. Okay. So next, 1 multiplied by 0.1 multiplied by 0.5. So it's minus 0.05 M plus. Right? See that you have taken minus. Sorry. See that you have taken minus. Otherwise, there will be wrong. Huh? It will be wrong. So next one, how much it is? This multiplied by this multiplied by this. Minus minus will become plus this time. 48 point. 48.28. The total. %79.10% square. Have you understood? This is 79.90%. Please copy. Done. Great. That's so fast. Chalo. Extended question. Okay, part 2. Calculate R. Calculate R. Understood? If you know R, see, if you know the, for R, if you know the covariance, formula is what? Covariance x comma y upon standardization of x into standardization of y. But we don't know the standard deviation. We have not calculated. Right? Correct. So we can, right? So I will directly make a column. Listen carefully. R minus R bar I have. First I will write probability, because probability I need, na? Then Rx minus Rx bar I have. Right? This also I have. This also I have. Ry minus Ry bar also I have, because I have calculated, na? What I should do to calculate the standard deviation? P multiplied by Rx minus Rx bar the whole square. I should square this and multiply by this. You remember? Same way, and then take the total. P multiplied by Ry minus Ry bar the whole square. Understood? Okay. Ry bar, Rx bar was how much? Sorry, copy this thing first. This Rx, column A, 21 134. 21 134. Correct? This is minus 34. Probability was how much? 0.3, 0.5, 0.2. correct? ry minus r bar, B column, 4.9 minus 0.1 and what? Minus 7.1. Understood? Now listen. Next column. Take this 21 into equals to 21 into equals to, it will get squared. Multiplied by probability 0.3. The answer is 132.3. You understood? Okay. One into equals to multiply by 0.5. It's 0.5. 0.5. 0.34 into equals to multiplied by 0.2. 34 is negative. 34 is negative. 231.2. What is the total? 231.2 plus 0.5 plus 132.3. The answer is 364. Am I right? Okay, this is variance. This is what? Variance of x. So I will take the square root. I will take square root. 364 square root. Standard deviation of x is equals to root of 364. How much? 19.08. Okay, percentage. Next, 4.9. ry minus ry bar the whole square. So 4.9 into equals to multiplied by 0.3 m plus, correct? Then 0.1 plus minus into equals to, anyways if you don't press into plus minus into, it's okay, into equals to multiplied by 0.5. Answer is 0.005 m plus, correct? 7.1 plus minus into equals to multiplied by 0.2, 10.082 m plus MRC. What is the total? Yes, root of 17.29. Answer 4.16%. Correct? R I know. R is what? Covariance of x comma y upon standard of x into standard of y. Okay, listen. Standard deviation can never be negative. Correct? Understood? And standard of y also can't be negative. That means if R is negative, it should get its value, negative value from what? From covariance. Right? So covariance answer was how much? Covariance answer 79.10. This is percentage square. Then you multiply this also na. This is in percentage. This is in percentage. Ultimately what becomes? Percentage square. So R becomes what? Units free. This gets cancelled now. This. Yes or no? So how much is the answer? I will take 79.1 divide by 19.08 divide by 4.16. Answer is 0.99. Plus, see it is positive. This sign I got from what? This covariance, the covariance 79.1. It shows what? It shows what? Positive relationship. It shows what? Positive relationship. Is that clear? Understood? But 79 does not mean anything. I'm again and again I'm telling this. Is that clear? 79 doesn't mean, only it is required to gauge the direction. So if it is positive, that means both are moving in what? Same direction. If you check here, na? If you check here, see when this was positive, this was also positive. This is positive, this is also positive. Understood? Here it is negative, but major things it is moving in the same direction, na? Same. So therefore it was positive. Is that clear? Understood? Okay. So please copy this last part if you want. So R of plus 1 na, plus 1 means it is almost positive, means it's very strong correlationship, and the relationship is what? Positive. Is that clear? That is the interpretation. Okay. So like this you can have a relationship. X can be a sense X. Okay, Nifty. And Y can be any particular stock, and you can establish, you can calculate R now. Okay.